students. You're welcome to ECO Learner Support for WAEC and NECO candidates. Today, I'm going to be your physics instructor. Take a ride along with me.
ECO Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Motion is the topic we'll be taking today. Motion. By the end of the lesson, and as the lesson progresses, you should be able to define motion, list types of motion, give the cause of motion, explain centripetal, acceleration, and force. What is motion? Motion involves a change of position of a body with time. It also involves how things move and what makes them move. Kinematics is the description of how objects moves without regard to forces causing their motion. And dynamics deals with why objects move as they do. We have various examples. You could see a boy here with a ball from a specific height. And you can see with the arrowhead showing us the movement of the ball. As the boy is bouncing the ball on the ground, that is a type of motion. And this is also another type of motion as is what? Throwing the ball upwards. Types of motion. There are 4 basic types of motion. From the diagram, you could see a boy riding a bicycle. That's a type of motion. You could see the pendulum swing. You could see a boy trying to do a high jump, which is also kicking a football. That is a projectile motion. It's also a type of motion, and this is also a type of motion. So the 4 basic types of motion are translational motion, oscillatory motion, random motion, and rotational motion. And these diagrams shows or depicts the types of motion we have. You could see a car, an apple falling from a tree. We have a ball, and we have the moving train. They all fall under these categories of motion. Translational motion. This is when a body moves from a point A along the line AB. Let me give you an example. Where I'm standing now is point A, and I want to move to point B. Watch me move. This is my movement. I am moving. I've gotten to point B. And my movement from point A to point B has given us what? That is the example of what? A translational motion. When a body moves from a point A along the line AB to another point B, we say that the body is translated from A to B. And the motion performed is known as translational. For example, when an aeroplane flies from Abuja to Lagos, or a car travels from Lagos to Enugu, we could also see the diagram depicting a train moving on the rail, showing us a translational motion. The train is either moving from Enugu to Lagos or Kano to Lagos. That is a translational motion. The second type of motion is oscillatory motion. In this type of motion, a body moves to and fro about a fixed point. To and fro about a fixed point. Examples are the vibration of a plucked guitar string, the motion of a pendulum as it swings back and forth. This is the diagram of a pendulum as it swings back and forth about a fixed point. And the vibration of the molecules of a solid. They are all examples of oscillatory motion. Rotational motion. This is the motion of a body which travels in a circle or the rotation of the eclipse about an axis. We've been talking about the movements that the earth rotates about its axis, and people wonder how does that happen. But the main example or the reason for that is we have the day and the night, and the rotation of the axis earth makes us believe that there is actually rotation of the earth about its axis. The rotation of blades of an electric fan about its axis, that is, we have a ceiling fan. This is what an example. You can see that it is on a fixed point and it is rotating about its axis. The rotation of a tap about a central axis. We have our tap in our houses. Once you move it, you can see that it is on a fixed mass and it's fixed axis, and it's what? It is moving in a circular motion. Another example is the random motion. In this type of motion, the body moves in a zigzag direction continuously so that they do not trace any definite paths. We have example of a fly buzzing around or a bee buzzing around, and you cannot depict the particular aspect or the particular path it is trailing. This type of motion is exhibited by molecules in gases. You can see this is example of, you can see the molecules does not have a particular path they are trending. Other examples of random motion is the Brownian motion, which is an irregular motion of particles or various kinds of particles suspended in water or smoke. Another very typical example is when you are in a dark place or a dark room. When you on your torchlight or any type of, or your phone torch, you will see those movements of particles through the rays of what? Of the light. That is an example of random motion. Causes of motion. We have been describing the motion of a body without regard to the cause of motion. Definitely, for there to be movement, there needs to be a cause. The cause of motion is force. Force is the cause of motion, and force is the pull or push of a body or an object. We have types of force. We have the contact force and we have the force field. For the contact force, this may be regarded as a force which exists between surfaces in contact. From the name itself, contact force. That is, a force which exists between surfaces in contact. It includes pushing or pulling, and frictional forces or reaction and tension forces is in strings and in wires. Like I told you, one of the example of motion then was pulling the string of a guitar or a violin. That is also an example of what? Force. So we need, for contact force, there needs to be contact with the surface. But for force field, these are forces whose sources do not require contact with the body to which they are applied. Examples are gravitational force, electrostatic, and magnetic forces. They don't need to be in contact with the surface or with the body before it experiences the force. So that is force field. The force is felt around in the surroundings. Gravitational force, electrostatic force, and magnetic force. They are examples of force fields. Practice question. What type of motion does a boy riding a bicycle from point A to point B along a straight line path undergoes? Number 2, differentiate between contact force and field force. 3, give 3 examples each on the following: translational motion and oscillatory motion. From the diagram below, beside, I believe you have your answers there, but let me leave you to pick the right answer for the question. I give you 30 seconds to do that. We'll be right back. Yes, I believe, my wonderful students, you have done justice to it. Now, let us go together and see how far you have learned in the question. What type of motion does a boy riding a bicycle from point A to point B along a straight path undergoes? The boy has undergone two types of motion. Translational motion, because the boy is traveling along a straight line from point A to point B. And the second one is rotational motion, because of the motion of the tire of the bicycle is moving in a rotational movement. So we have, for this first question, the answer is translational motion and rotational motion. And I've given us the reason why it is translational motion and why it is random motion. The second question, differentiate between contact and field force. Like we rightly said, we have, for the contact force, the body has to be in contact with the surface. That is the force which exists between the surface that is in contact with. While the field force does not need to be in contact with the body. It does not require to be in contact with the body. That is for the second one. Then the third one, give 3 examples of the following. Translational motion. We gave you an example the first time. We have one here. You can see she moved from one point to another. Then we have the boy riding a bicycle from point A to point B, or a car traveling from Enugu to Lagos, or an aeroplane traveling from Kano to Lagos. Oscillatory motion. We have the example for oscillatory motion. We have the pendulum bob. We also have the plugged guitar string, and we have a swing, like they used to call it my grandfather's chair, moving about its fixed points. Those are examples of oscillatory motion and translational motion. So that is what we'll be taking for the class today. For any other question, observation, comments, kindly visit the link on the screen. Thank you for listening. See you in the next class.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the ECO Learner Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch ECO Learner Support for WAEC and NECO candidates on this station. Learners can also connect with ECO Learner Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. ECO Learner Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Good day, students. You are welcome to ECO Learner Support for WAEC and NECO students. I'm going to be your tutor for today to take you on physics, and the topic is electricity. Let's ride on.
ECO Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
The learning objective for today are as follows. You are expected at the end of today's teaching to be able to describe electricity, basic quantities of electricity, state Ohm's law. You are expected to explain each quantity of electricity and to be able to state factors affecting the resistance of a conductor. What is electricity? Electricity is the study of charges. When we talked about charges, charges could either be at rest or in motion. When charges are at rest, they are referred to as static electricity. But when charges are in motion, it is referred to as current electricity. When we talked about electricity, we cannot finish it unless we talked about electric circuit. What is electric circuit? Electric circuit is a part provided for the flow of electricity. And when we talked about this circuit, there are three types of circuit: open circuit, closed circuit, and short circuit. An open circuit is a circuit with an opening in the conducting part. That is, the key is opened. While a closed circuit is a circuit in which there is no gap along the conducting part. That means the key is closed. And the third one, the short circuit, is a closed circuit which have no load on it. The diagram you can see on the board is an open circuit. The key is open, and that is why there won't be any light shown on the bulb. We want to look at basic quantities of electricity. There are three basic quantities of electricity. They are the electric current, the potential difference, and the electric resistance. Let's take them after the other. Electric current. Electric current is the time rate of flow of charge in a conductor. Electric current is denoted with alphabet I, and just like the definition I've rightly said, is Q over T. The Q there is the quantity of charge, and the T there is the time. We need to know that electric current is measured in ampere, but based on what we have on the board mathematically, because charge is measured in coulomb and time is measured in second. That means under derived quantity, we can also have coulomb per second. So electric current has two units: fundamental units, which is ampere, and derived unit, which is coulomb per second. Let's move on. The next one, electromotive force. Electromotive force, which is normally referred to as EMF, is the potential difference between two terminals of a cell when it is not delivering any current in the circuit. I need to quickly explain here. When you have a circuit, and in that circuit, you just have voltage flowing through it. The moment the total driving force in that circuit is called electromotive force. But when it starts giving back to, it gives back to potential difference. Potential difference. This is the work done in joules when one coulomb of electricity moves from one point to another. And the last one, electric resistance. Electric resistance is the opposition to the flow of current in a circuit. You need to know, when we talk about opposition, we are talking about a barrier. That means the bigger the resistance, the smaller the amount of current that will flow through the circuit. So when we get into calculation, you will agree with me, since we can liken resistance to mountain, to something that inhibits your progress. So when we get to calculation, the more you see, the higher the resistance, the lower the amount of current, because we say is the opposition to the flow of current in the circuit. These three basic quantities of electricity that we mentioned, which are potential difference, electric current, and electric resistance, are bound together by a law propounded by George Ohms, which is referred to as Ohm's law. Ohm's law says that the electric current passing through a metallic conductor is directly proportional to the potential difference across the end, provided the temperature and other physical factors are kept constant. Based on that theory, you will agree with me, using mathematical form of it, V is directly proportional to I. And when we remove, based on mathematics, when you remove proportionalities and you introduce a constant, and the one who works on it is by name called George Ohms. So we give it R. V is equal to IR. V is the potential difference, I is the electric current, and R is the electric resistance. Potential difference is measured in volts, electric current is measured in ampere, and electric resistance is measured in ohms. What are the factors affecting the resistance of a conductor? You are expected to know. Number one factor affecting the resistance of a conductor is the nature of the material, which is otherwise referred to as resistivity. The cross-sectional area of the conductor, the length of the conductor, and the temperature. These are the four factors that affect the resistance of a conductor. Now that we have come to the end of this lesson, I believe you have understood. For 30 seconds, I will give you a question to practice. What are the practice questions? Number one, draw 5 electrical symbols and their names. 2, differentiate between EMF and potential difference. 3, what is the significance of the slope of the Ohm's law? And 4th one, what are non-ohmic conductors? Give example. I'll be right back in 30 seconds. I believe you must have done justice to those questions. But let us see and cross-check what you have. We talked about 5 electrical symbols and their name. Number 1, we have the galvanometer. This is the symbol for galvanometer. We have the voltmeter for measuring the potential difference. Galvanometer does 2 things. It measures very small amount of current, and it also detects the flow of current. The next one is ammeter. Ammeter is used for measuring the amount of current flowing in a conductor. Note, it must always be connected in series. We'll learn that in our next slides. Voltmeter, like I said, is for measuring the amount of potential difference flowing. It must also be connected in parallel. What do we mean by that? In our next class, we'll know that. We have the symbol for capacitor. This is the symbol for capacitor. You can see they are of the same height, which is different from that of cell. That of cell, we have the long and we have the short. But capacitor is of the same size. And last but not the least, the 5th one, we have the battery. Battery, we all know, battery is a combination of cells. Is a combination of cells. Difference between EMF and electromotive force. I told you earlier, I said EMF, electromotive force, is the potential difference between 2 terminals of a cell when it is not delivering any current in an external circuit. Why potential difference is the work done in joules. When one column of electricity moves from one point to another, I also need to let you know that the moment it starts delivering, it is no more EMF. And that is why EMF, it has internal resistance, except otherwise stated that it is negligible. So EMF is like the mother, total driving force, while the children given back to are the potential difference. Note that EMF is the mother and gave back to potential difference. What is the significance of the slope of Ohm's law? The significance is that it denotes the resistance of the conductor. From the slope, when you are able to get the slope of the graph, what you obtain is the resistance. And lastly, we talked about what are non-ohmic conductors. We talked about Ohm's law. Don't forget, so Ohm's law states that the metallic current passing through the electric current passing through a metallic conductor is directly proportional to the potential difference across the end, provided the temperature and other physical constants are kept constant. But example, we have most metals, but materials that do not obey Ohm's law are referred to as non-ohmic substances. In other words, non-ohmic conductors are conductors that do not obey Ohm's law. An example, we have the semiconductor, which is silicon, germanium, transistors, diode, thyristors, etc. On this, we draw the curtain for today.
ECHO Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
For comments, observation, and any question, contact us on the social media display on the screen. Good day.
Thank you.